Hello everyone. I welcome you all to this session of JEE Mathematics. We will be covering all the chapters in this course, right? And right now we are on 23rd module, that is of previous year questions related to continuity. We have already covered this chapter in our last session. Day before yesterday we have covered this chapter. So today we will be trying the previous year questions related to this chapter. I hope you have tried some questions related to this chapter so that you have a grip of this chapter. Now we will solve such few questions of previous year question over here, right? So before beginning further, let me just tell you what Practically platform exactly is. Practically is an e-learning platform where you get courses related to mathematics and sciences from grade 6th till grade 12th. So whomsoever you know from grade 6 till grade 12, just share this link with them so that they can also be benefited with the lectures we provide over here, and also we provide 3D model videos on our application that definitely will give you much more clarity of the concepts when you see the 3D model videos, right? So for that you need to download our application, and in that you will get list of all the courses which are available over here. Some are paid, some are free, so you can get avail all such courses over there from our application, and you can get enrolled with us on our paid platform, so in as many courses as you like. Okay, there is no foundation that you can only enroll with 1 or 2 courses. You can get enrolled with us in as many courses as you like. There will be much more interaction if you get enrolled with us in our paid platform, right? Otherwise you can get 3D model videos for better conceptual clarity of content. For that you need to download our application from your Play Store. Okay, so let's begin with the session, but before that I'll just say that do share this link with your friends so that they can also be present over here to enjoy our live session and get more interaction over here. Just quickly share this link with your friends, and we will begin soon with our previous year questions related to continuity. This was very small chapter, so you will be enjoying learning over here with previous year questions, because 1 or 2 basically the concepts which will be used in most of the questions, right? So if you solve all the questions over here with me, definitely your continuity part would be great if you are able to solve and understand all the solutions over here. So let's just begin. Here's the first question for this particular session, and it is numerical answer type question. What does the question ask exactly is, let f of x is equals to x into greatest integer of x by 2 for x belonging to minus 10 to 10, where 10 is not, and minus 10 as well as 10 is not included. And this basically rectangular brackets basically gives you the greatest integer function, it tells you over here. Then the number of points of discontinuity of f is equal to, when x is in this interval, open interval minus 10 to 10, we basically need to calculate the number of points of discontinuity. Means in total how many discontinuities we have over here. So for that we will check for all the discontinuities we have. Let's just check. Here we have f of x as multiplication of 2 functions, right? It has multiplication of 2 functions. First function is say x only, and second function is greatest integer of x by 2, right? Second function is greatest integer of x by 2. So first function, which is just x, which is some kind of a polynomial function, alone x is of some polynomial function which will always be continuous. So there is no issue from this side, that is for x only. The issue will only be from the second one, that is greatest integer of x by 2. Greatest integer of x by 2 is discontinuous at each and every integral point. So we need to check in this particular interval, when do we get this value x by 2 as integer. That's it, right? Let's just check for it. We have all the numbers in between minus 10 and 10. Do care that you don't have minus 10 and 10, otherwise your answer will be reflected with the same thing. You don't have minus 10 and 10 with you in question. Okay, let's just see how we will see like solve for it. We have x by 2. When will x by 2 be integer? X by 2 will be an integer if x is equals to either plus minus 2, plus minus 4, plus minus 6, plus minus 8, as well as 0, right? At all these points inside this given interval, this x by 2 will be integer. So this implies x by 2 is discontinuous at x is equals to plus minus 2, plus minus 4, plus minus 6, plus minus 8 and 0. Okay, now at all the numbers from plus minus 2 to plus minus 8, you will be getting the left hand limit and right hand limit of this function f of x will be different. But let us just check for this point 0, because if you have 0 point as the discontinuity when two functions are multiplied, do check for 0. I do recommend just do check for 0. There might be the discontinuity at 0 or there might not be. There's some like thing where 0 might be continuous. If it's just looks like discontinuous, do check at 0 always. So let's just check for 0. So at 0, f of 0, functional value at that point is 0 into greatest integer of 0 by 2, that is 0. Let's just check limit x approaches to 0 from plus like positive side, x into greatest integer of x by 2, that is same as limit h approaches to 0, 0 plus h into 0 plus h divided by 2, that is same as limit h approaches to 0, h into h by 2, right? So this is same as 0. Okay, because as h approaches to 0, so h by 2 will tend towards 0 and h is already tending towards 0, so 0 into 0 will definitely be 0. So you have your right hand limit over here as 0. Now let's just check for left hand limit, that is limit x approaches to 0 from negative side, that is from left hand side of x into greatest integer of x by 2, that is same as limit h tends to 0, 0 minus h into 0 minus h by 2, that is equals to, here this 0 minus h by 2, this will be minus 1, right? Limit h tends to 0, this greatest integer value will definitely be minus 1. But minus of h, here you have minus of h, that always tends to 0. So here you have functional value at 0 as equal to 0, right hand limit is 0, even left hand limit is 0. So if functional value as well as your right hand value as well as your left hand value, all three are equal, that means at that particular point, your function is continuous. If your function is continuous at 0, so that implies for in all the points of discontinuities of x by 2, we need to exclude this 0 so as to check for the discontinuities of f of x. This implies f of x is discontinuous. This is just the short form of discontinuous. F of x is discontinuous at x is equals to plus minus 2, plus minus 4, plus minus 6 and plus minus 8. In total you have 8 points. That means number of discontinuities of f is equal to 8. 8 was your answer for this numerical answer type questions, which was in your 2020 question paper. Okay, so I hope you have learned how to solve this question, right? What we did is we splitted the given function into two functions as the multiplication, and first function was our continuous function. We checked for the discontinuities of the second one. After checking for the discontinuities of second one, We have checked for 0 because 0 was there as the discontinuity point of discontinuity for the second function. We always check for 0 because sometimes it seems that at 0 the function must be discontinuous, but it comes out to be continuous, as in this case, right? So you need to check for 0 always. You can even check for other points if you have time. So definitely check for 0, otherwise you have marked 9 as your answer, which would be wrong. Okay, so do check for 0, and after checking for 0 we got that we are only left with 8 points, right? So the answer is 8 for this particular question. Let's just move further to the next question. Here's the next question for you. If the function f of x defined by f of x is equals to, like here all the value functionals are given to you from -1 to 1, 1 to 3 and 3 to 4. For 3 intervals, 3 different set of functions are given to you. This is continuous for some values a, b and c. The function f of x which is given to you, this is continuous, it is given to you for some values a, b and c. They haven't given us the values of a, b and c, but there are certain values which exist for a, b and c for which this function is continuous. That's what they have told to us. Okay, and f dash 0 plus f dash 2 is equals to e. There's one more equality given to you, this one, f dash 0 plus f dash 2 is equals to e, right? This exponential value, like here also e is included. So then the value of a is, we need to calculate the value of a and check from the options which option is correct. Okay, so let's just check for this. Let's just only have this function, we have only this function, and we know that the function is continuous. This function is continuous. This function is continuous, and we have one more, this equation given to us. So let's just see, we have f of x as continuous. That means at the point 1, x is equals to 1, as the function is continuous. That means for all the points -1 to 4, for all the points x equals to -1 to 4, your function would be continuous, right? So that means f of x is continuous. F of x is continuous at x is equals to 1 as well as at x is equals to 3. Now let's just take at, if the function is continuous at x is equals to 1, how can we like have some equation in terms of a, b and c from this particular thing? If the function is continuous at x is equals to 1, that implies f of a1, that is functional value at 1, is same as right hand limit at x is equals to 1, is same as left hand limit at x is equals to 1, right? And even if the function is continuous at x is equals to 3, that means f of 3 is same as right hand limit at x is equals to 3, and it is same as left hand limit at x is equals to 3. We will use these two equations, basically these two concepts, so that we have two equations at least with us, and third equation is already given to us. So let's just deduce something from over here, right? We have f of 1 is equals to right hand limit at x equals to 1 as well as your left hand limit at x equals to 1. You know that f of 1 is same as this function, right? So your right hand limit would also come from this function. So equating it to right hand limit will not give you anything new. So what we will do, we will equate it to left hand limit only. Okay, so let's just equate this to left hand limit only. So we have f of 1 same as left hand limit at x is equals to 1. So just equate this. We have f of 1 is c into 1 square. We have this function at x equals to 1. This is same as limit x approaches to 1 negative, function at 1 negative, that is just at the left side of 1, that is same as this first function. So that is a e raised to power x plus b e raised to power minus x. right? So this gives you C is equals to limit x approaches to 1 negative. You can directly put the value 1 over here because this doesn't give you anything as indeterminate form, or which form that the limit can easily be calculated by just the substitution over here. So a e raised to power 1 plus b e raised to power 1 we have, minus 1 we have, okay, we will put x is equals to 1, so minus of 1 we will have. So this is the equation we got till now. Now let's just have the another equation which we can find over here from this f of 3. Okay, so we have f of 3 is same as right hand limit at x equals to 3 as well as equals to your left hand limit at x equals to 3. So if you check for left hand limit of x equals to 3, for x equals to 3, you will have this function which is same as f of 3, right? Same function will be used for left hand limit as well as the functional value. So what we will do is we will equate over here with RHL, that is your right hand limit at x equals to 3, so that we get something equation, some new equation with us. Okay, so we have f of 3 is same as c into 3 square, that is same as limit x approaches to 3 from positive side, right hand limit is from positive side. So we have over here a x square plus 2cx, this is what we have. So that is equal to, just put the value of 3 directly over here, you will have 9a plus 6c, this is same as 9c. That implies you have 9a is equals to 3c, which gives you c is equals to 3a. You got c in terms of a. From first one, you can write b in terms of a. How would this be helpful? We will see. Right, we are basically, what we are doing is we are writing all the given variables a, b and c. A was already like independently we are treating it because we need to calculate for a. We are writing b and c, two other variables which we are having in terms of a. Right, so we have c in terms of a. Using this we can write b in terms of a. How? You have c is equals to 3a over here, right? I am marking this as star. So we have from star, right? From star we have c equals to 3a, so just put in the left hand side as 3a, that is same as a into e plus b into e raised to power minus 1. So you have 3a minus a into e is equals to b into e raised to power minus 1. That implies b is equals to, e can be taken to the other side and from this a can be taken out common. So you have 3 minus e. So this is what you have, b in terms of a. Now you have c in terms of a, b in terms of a. You need one more equation because you are having 3 variables. So if you are having 3 variables and you need to calculate the value of any one at least, so for that you need 3 equations. Already we have found the value of c and b in terms of a from 2 equations. Now we need one more equation to find the value of a, right? For that we are given with one equation, that is this one. So from this we will be calculating the value of a. How? Let's just see. Just substitute the value of f dash 0 and f dash 2 from the given function, right? So f dash 0 from the given function would be same as 0 lies in this interval. So f dash 0 will be from this interval. That implies from for f dash 0 what function you will have. For that you will have, just differentiate this first one. Just differentiate this first one. So you will be having a into e raised to power x minus of b into e raised to power minus x. This is what you have the for the value of f dash 0. Just put x is equals to 0 over here. So you have a e raised to power 0 minus b into e raised to power minus of 0, that is same as a minus of b, right? Now just check for f dash of 2. 2 lies in the second function, like second interval. So you have differentiation of this is 2 into c into x. That implies f dash of 2 is same as 2c into 2, that is 4 times c. Now you have f dash 0, you have f dash 2. You can easily calculate the value of a from this equation. Let's just calculate this. We have f dash 0 plus f dash of 2 is equals to e. Right, f dash of 2 we have calculated, it is a minus b, plus f dash of 2 we have calculated this one also, that is 4 times c. So 4 times c is equals to e. Now what we will do to calculate the value of a, we will find the value, like write the value of b as well as c in terms of a. Right, so a will be right again as it is minus of b. Over here we were having b is equals to ea into 3 minus e, so that is e into a into 3 minus e plus 4. C over here, you can see c was 3 times a, right? So you have this as thrice of a, that is e. Okay, so you have a, right, minus of 3ea plus of, you have e square a plus of 12 of a is equals to e. This is what you have. Now just you can see that in all the way, like all the terms in the left hand side, you have a common, so you can take a common. So you have 1 minus 3e plus e square plus of 12, that is same as e. So a would be equal to e by e square minus 3e plus of 13, just 12 plus 1 is directly 13. So you have this value for a. So for according to this, your answer would be this D part, e by e square minus 3e plus 13. Okay, so let me just recall all the steps we did for this question. Is firstly, we were given with the function as continuous. So if the function is continuous, that means at these points where the function is changing at x equals to 1 and x equals to 3, at that 2 points we will have the function to be continuous, because it is given that overall the function is continuous, right? So for using the definition of continuity, we made 2 equations, we created 2 equations using definition of continuity, right? So from those 2 equations and the third equation which we were given with, we tried for like simplifying it so as to calculate the value of a, right? We have already formed like you can even use some other procedure to solve. Okay, so we are done with this. Let's just solve the another question we have. So we have this question with us, right? This is the next question we have, right? So let's just calculate this one. Okay, so let's just solve. We have, let this denotes the greatest integer function which is less than equal to t, right? This denotes the greatest integer function, which you know. We have limit of x approaches to 0, x into greatest integer of 4 by x equals to a. We have this thing with us. Then the function f of x is equals to this greatest integer of x square into sine of pi x is discontinuous when x is equals to. We have this value a from here, from this first limit. We can easily calculate this value, right? Now using that value, we need to basically mark the options, right? So if you calculate the value of a, only then you will be able to solve further. So first let's just calculate the value of a. So we have this function with us. Let's just write what we have. Limit x approaches to 0, x into 4 by x is equals to a. This is what we have. Let's just calculate the value of a. A is equals to limit x approaches to 0, x greatest integer of any expression can be rewritten as the actual value minus the fractional part of that expression, right? So I have molded this out. How I have written this, any expression, like if we have f of x and greatest integer of it, that is same as f of x minus the fractional part function of that function, right? So same function same expression you have, just subtract the fractional value from it, right? So I have written this out like this. So that is limit x approaches to 0, we have this as x into 4 by x, that is same as 4, minus x into greatest in like x into fractional part of 4 by x. This is what we have. This is same as a, right? Now we know that this value, this particular value, this lies in 0 to 1, 0 included and 1 not included. So this is some finite value basically. This is some finite value, right? So some finite value in this, into this x tends towards 0. So 0 into some finite value would definitely be 0. So that implies your a is equals to 4. Now as you have a equals to 4, now let's just check for the discontinuities of this function basically. You can see that here discontinuities will be according to this greatest integer function as well as for sine of pi of x. But at all the values where this greatest integer function is discontinuous, you can see that sine of pi of x will be 0. So that implies what we need is, you need just the non-integral point. At all the non-integral points, your function f of x, function f of x is discontinuous. So let us just check for the non-integral points from the options. Let's just check. We need to check the non-integral points from the option. We are having a equals to 4. Now let's just put the value of a as 4 in all the options. D option will be under root of 4, that is 2. This is not a non-integral. This would be under root of 25, that is same as 5. This would be 4 plus 5 under root 9, that is same as 3. So all these 3 are integers, so you need to neglect them. This one would be under root of 5, which is non-integral. That implies your a part would be the correct answer. Okay, so you have a part as the correct answer for this particular question. Here's the next question for you. If the function f is defined on this interval, your given function, this f of x, is defined from minus 1 by 3 to 1 by 3, okay, and it is defined as 1 by x log of 1 plus 3x over 1 minus 3x when x is not equals to 0, and when x is equals to 0, then it has the value k, and we are supposed to find the value of k from this given information. As we are having the function to be continuous, right? We have function as continuous. That implies at the point where the function changes, it is even continuous at that point, and the function is changing its value at x equals to 0. So we need to check for that point only, so that we have some equations over here. So according to the continuity, according to the definition of continuity, right, as the function is continuous in minus 1 by 3 to 1 by 3, this implies function is continuous at x equals to 0. If it is continuous at x equals to 0, so according to the definition of continuity, you have left hand limit at x equals to 0 is same as right hand limit at x equals to 0, or you can say limit f of x at x equals to 0 is same as f of 0. You have all this using the definition of continuity. So we will just use the definition of continuity to solve this question. Okay, so we have f of 0 is same as k over here. You can see f of 0 is same as k, and that is what we are supposed to calculate. So k is same as limit x approaches to 0 f of x. Just put the value of f of x over here, that is limit x approaches to 0 1 by x log base e 1 plus 3x over 1 minus of 2x. This is what you have. Okay, now you need just the basic property of logarithm, right? So you have like a basic logarithmic property with you, as if you have log of like m by n, this is same as log m minus log n. Yeah, hello Kalki. That's good, you have understood till now. Let's just solve this question. We have this function with us. So using this logarithmic property, we will just write this function again. Limit x approaches to 0, 1 by x. This is log with base e 1 plus 3x minus of log of 1 minus 2x. This is what we have. Now just write this x with each of the logarithmic value, right? So you have limit x approaches to 0 log with base e 1 plus 3x divided by x minus of log of 1 minus 2x divided by x. You have this with you, right? Now just recall that you have log of 1 plus f of x divided by f of x. When limit f of x approaches to 0, this value comes out to be equal to some, like it is predefined value for you. What does this value exactly is? This value is always 1, right? This value is 1. So we need same function here and in the denominator. 1 plus some function is, and the same function must be there in the denominator. That means here if we have 3x, we want 3x in the denominator. So what we will do is we will multiply by 3 and divide by 3 the function, right? So we have 3 and 3 multiplied and divided, so that the function's value is not changed. Okay, and here also you have minus of 2x, so you need minus 2 over here as well as you need minus 2 over here, right? So that implies this would be equal to, this complete value would turn out to be equal to 1, and this complete value would turn out to be equal to 1. That implies you will have 3 into 1 minus of minus 2, minus of minus 2 into 1, that is 3 plus 2, same as 5. So you have your numerical type question over here with you, so you just need to write the answer as 5. Okay, so 5 is your answer for this particular question. Is there any doubt in this question? If there is any doubt, just let me know. Any doubt? Okay, here just the one basic property of logarithmic over here is used, and rest we have just used the definition of continuity. A similar question we have as next one, this one. Just try it out once yourself. Here again we have the function f defined on pi by 6 to pi by 3 interval. Open interval from pi by 6 to pi by 3, our function is defined by f of x is equal to, how it is defined, for x equals to pi by 4 we have the value k, okay, and for x unequal to pi by 4 we have this function under root of cos x minus 1 divided by cot x minus 1. So is continuous when k is equals to, we need to check for the value of k. What is the value of k? Again we will use the definition of continuity, and what we are basically supposed to calculate the limit of this particular function, right? So let's just check. According to definition of continuity, we have limit x approaches to pi by 4 of f of x is same as f of pi by 4. F of pi by 4, we know this is equals to k, right? So we need to calculate the value of k, that is same as limit x approaches to pi by 4 f of x. Just input the value of f of x over here, whatever expression or function you have. So limit x approaches to pi by 4, this is under root 2 cos x minus 1 divided by cot x minus 1. You have this function with you. Is this function directly this limit directly calculatable if you just substitute the value of x equals to pi by 4? Check. If you directly substitute the value as pi by 4, are you able to calculate? If you input the value of pi by 4 in this particular function, what would be your value in the numerator and denominator? Numerator over here, numerator would be equal to under root 2 cos of pi by 4. Cos pi by 4 is 1 by under root 2 minus of 1. So this is 1 minus 1, that is 0. Your numerator is 0. Now check for denominator. Your denominator is cot of pi by 4 minus 1. Cot pi by 4 is 1 again. So 1 minus 1, this is again 0. So basically you are having 0 by 0 form with you, right? If you are having 0 by 0 form, and even you can see that cos x as well as this cot x in this particular interval, both the functions are continuous as well as differentiable. That implies now you can easily apply the L'Hopital rule over here. So according to the L'Hopital rule, this limit would be same as limit x approaches to pi by 4. Limit value remains the same. What we did in L'Hopital rule is basically we differentiate the numerator as well as the denominator separately, right, and equate the value. So under root of cos x minus 1. So differentiating this would be under root 2 as it is. Cos x is same as minus of sin x. Differentiation of cos x is minus of sin x, and differentiation of cot x minus 1 would be minus of cosecant square x. That is same as this minus would be cancelled out. So you have limit x approaches to pi by 4 under root 2 sin x, and this cosecant square x is same as 1 by sin square x, so you come out to be equal to sin cube x. That is under root 2 sin cube of pi by 4. You can easily input the value now. So you have under root 2 1 by under root 2 cube of it. So you are left with 1 by 2 only. So you have the value of k to be equal to half. So you have your value as half for this particular function. Any doubt in this question? You can ask me if you have any doubt. Okay, so I suppose there is no doubt. So let's just move to the next question. Here's the next question for you. If f of x is equals to greatest integer x minus of greatest integer of x by 4, as for all the values of x in the real line, right, where this denotes the greatest integer function. We have already read this as greatest integer function, so we know that this is greatest integer function by now. Then we need to select the correct option. We have options as f is continuous at x equals to 4. Next option is limit x approaches to 4 plus, that is right hand limit at x equals to 4 exists but left hand limit does not exist, right. Next is both the limits exist but are not equal, and next is left hand limit exists but right hand limit does not exist. And you can check in all the options you are having the point x equals to 4 only. So what is your main task? Directly this is not given to you in the questions. What you have done is you read all the options and you checked how you need to proceed. In all the options you are mainly dealing with the limit, left hand limit as well as the right hand limit at x equals to 4 point. So let's just deal with that point only. So we have this function with us. We have this function with us. Now we need to check left hand limit as well as the right hand limit at x equals to 4, right? So that we can mark which option is correct and which is not. Okay, let's just mark and check and mark. Limit x approaches to 4 from positive side. Right now I am calculating for right hand limit. Okay, that is f of x, limit x approaches to 4 from positive side of f of x, that is same as limit x approaches to 4 from positive side greatest integer x minus greatest integer of x by 4, right? You have this with you. Now if your number is greater than 4, if your number is just a slight greater than 4, it's just slightly greater than 4, that implies your number lies in between 4 to 5 basically. If your number lies in between 4 to 5, the greatest integer functional value would be equal to, if your x lies in this, that implies greatest integer x will be equal to 4, because a number which is an integer and just less than 4, if your x is just greater than 4, that would be 4 only. Now x by 4 you need to calculate. Your x is just greater than 4, just consider it to be 4.00001, suppose, right? And divide by 4. So its greatest integer value would be, if you divide this, you will be having 1.00025, something like this. So that implies your greatest integer value would be equal to 1. So just input the value. You have this first value as 4 minus second value, that is 3. Now let's just calculate the left hand limit. You have limit x approaches to 4 from negative side f of x, that is same as limit x approaches to 4 from negative side greatest integer x minus greatest integer of x by 4. Now again you need to check, as you are approaching towards x from the negative side of 4, right? So that implies you are in the interval 3 to 4. If you are in the interval 3 to 4, that implies greatest integer x value would be 3 and greatest integer of x by 4. Take any value in this 3 to 4 interval. You will have x by 4 as 0 point something, like it can be 0.99999, but still it is 0 point something. That implies its greatest integer value would be 0. So you have this value as 3 minus 0, which is same as 3. Now you can see your right hand limit is 3, your left hand limit is 3. Now just check for f of 4, functional value at 4. So that is greatest integer 4 minus greatest integer of 4 by 4, that is 4 directly minus of 1, that is 3. That implies your right hand limit, left hand limit and functional value at that point all are equal, and those are equal to 3. That implies your function has existing limit as well as it is equal to its functional value. That implies it is continuous. So you have A part as your answer. All other options are neglected because in this one you have LHL does not exist, which is not true, and here in the C part not equal is given, which is not true, as well as in this RHL does not exist is given, which is not true. You are left with only A part, which gives you f is continuous at x equals to 4. Okay, so next question, let's practice out. If there is any doubt in this question, let me know. Is there any doubt in this particular question? Okay, let's just move forward. So we have this question. If the function f of x, it has different values and the function is plotted at the point x equals to 5. It is a into absolute value of pi minus x plus 1 when x is less than equal to 5, and it is b into absolute value of x minus pi plus 3 when x is greater than 5. It is given to you that the function is continuous at x equals to 5. Then the value of a minus b is what we need to calculate. right? Let's just calculate. Okay, so we have this function with us and the function is continuous at x equals to 5. If the function is continuous at x equals to 5, that means your left hand limit at x equals to 5, your right hand limit at x equals to 5, as well as your functional value at x equals to 5, all three are same. This is using the definition of continuity, right? So we have these three values equal. Let's just equate them. We have limit x approaches to 5 negative f of x is same as limit x approaches to 5 from positive side of f of x. Just input the value of f of x over here, like whatever different expressions you have. If if x approaches towards 5 from negative side, that means it is less than 5. So you have first function with you. So limit x approaches to 5 from negative side, a into pi minus x plus of 1, that is same as limit x approaches to 5 from positive side. So if it is approaching from positive side, that means x is greater than 5. So you have second function with you, b into x minus pi plus of 3. Now you can see that you can easily calculate both the limits. How? Just substitute the value of x directly as 5. You will be able to calculate the limit. So this limit would be a into pi minus 5 plus of 1, that is same as b into 5 minus pi plus of 3. We are supposed to calculate the value of a minus b because we want the value of a minus b according to the question. Let's just find the value of a minus b from this only. We have only one equation. No more equation can be formed from the given data. So that means answer would be there in this particular equation only. Like we just need to simplify it. Okay. So let's just simplify. You have this absolute value of pi minus 5. You know the value of pi, you know the value of 5, like 5 is like absolute number you have. You know the value of pi, you have, that is 3.141 approximate, like, so if it is 3 point something and 5 is greater than that value pi, so absolute value of this would be 5 minus pi, right? Absolute value means the positive quantity. So 5 minus pi, 5 minus 3.14 would be positive value. So that implies this absolute value of pi minus 5 is same as 5 minus pi. So a into 5 minus pi plus of 1, this is same as, now again you are having absolute value of 5 minus pi. This is positive value already. So you have 5 minus pi directly, b into 5 minus of pi plus of 3. You are supposed to calculate the value of a minus b. So for that what you do is you will take this on one side and rest onto the other side. So you have a into 5 minus pi minus of b into 5 minus pi is equals to 3 minus 1, which is 2. So take this 5 minus pi common from left hand side and take it to the other side. So you have a minus b is 2 by 5 minus of pi. So you have a minus b as 2 by 5 minus of pi. This is your answer. Okay, so is there any confusion in the solution? Directly what you did is you use the definition of continuity. How you use the definition of continuity? You are already given that the function is continuous at x equals to 5. If the function is continuous at x equals to 5, that means you can use the definition of continuity at that particular point. So you have equated left hand limit as well as right hand limit, and if it would be needful, we would have equated it to the functional value. That might not give you something new over here, but if the function is splitted out in the 3 functions at x equals to 5, you are given with some new functions, so definitely it would be helpful, right? Then for this particular question, equating left hand limit and right hand limit was sufficient to give you the answer. Okay, let's just move to the next question. Here's the next question for you. Again, you need to find the value of k for given function to be continuous at x equals to 2. There's some given function to you which has its the function is changing its value at x equals to 2. Like, so it is given that it is continuous at x equals to 2. So using that, you need to calculate the value of k. Just try this out. We have tried this question, this type of questions 2 or 3 times, right? So you just need to calculate the limit. So again, I'm this time writing it directly. What we can do is, we have f of 2 is same as limit x approaches to 2 f of x. This is using definition of continuity, right? So using definition of continuity, we directly have this thing. So just put the value of f of 2 over here, that is same as k. That is what we need to calculate. So we have this as limit x approaches to 2 f of x is x minus 1 raised to power 1 by 2 minus x. Right. Basically, while doing the questions of continuity, what you are doing is you are like practicing for the questions of limits, right? The main target throughout this chapter, you might have seen, you are calculating limits again and again. That's why I stressed more over the limits part, because if your limits portion is weak, then you might feel some difficulty for calculating and evaluating the questions for continuity or differentiability. So if you are feeling that your continuity part is not good, that means your limits part is not good, right? There is nothing much new in continuity. In continuity, you just have definition or 2 to 3 main results which you need to apply everywhere. Okay, so let's just calculate limit x approaches to 2. If you put the value of 2 directly over here, that means your function would be 2 minus 1 raised to power 1 by 2 minus 2. That is 1 raised to power 1 by 0. 1 by infinity form you have. If you have 1 by infinity, 1 raised to power infinity form, so 1 raised to power infinity form, for that what you do is, we have the result as limit x approaches to some value 0 or some value a, 1 plus f of x whole raised to power 1 by g of x. If this is 1 raised to power infinity form, this is same as e raised to power limit x approaches to a f of x by g of x. So what we will do, we will use this formula directly. Okay, for that you need to write this function as 1 plus some function. That means you have x minus 1, so you can write this as 1 plus x minus 2, right? And in the power you have 1 by 2 minus x. So that implies your f of x here is x minus 2 and your g of x here is 2 minus x. So this would be equal to limit x approaches to 2 e raised to power f of x, that is x minus 2 divided by g of x, 2 minus x, that is e raised to power minus 1, right? This x minus 2 and 2 minus x, this would be cancelled out. You will be having just 1 minus of 1. So e raised to power minus 1 is the answer for this particular question. We have k value to be equal to e raised to power minus 1. Okay, let's just calculate for the next question. Here's the next question for you. The value of k for which the function f of x is equal to 4 by 5 raised to power tan of 4x divided by tan of 5x is continuous at x equals to pi by 4. Again, pi by 2, x equals to pi by 2. So you have at x equals to pi by 2, your function is continuous. And your function is changing, basically your function is splitting at that same point. So you need to equate for that only point. So let's just equate. We have, again, same definition is used throughout in this particular chapter. You need to practice on limits mainly. So you have limit x approaches to pi by 2, f of x is same as f of pi by 2. So f of pi by 2 is k plus 2 by 5. That is same as limit x approaches to pi by 2, f of x over here is 4 by 5 raised to power tan of 4x by tan of 5x, right? So what I'll do is I'll change the tan of 5x as sine of 5x by cos of 5x, because in that case it would be easier for you to calculate. Otherwise it would have formed 0 by like tan of 4 into pi by 2, like this 0 by something else, not defined form. So for that, just eliminating that thing, what we would do, we would rewrite this function as x approaches to pi by 2, 4 by 5 raised to power tan of 4x by sine of 5x into cos of 5x. Why we have written it like this? Just see, if you put the value of x as pi by 2 directly over here, right, you would have tan of 4 into pi by 2 divided by tan of 5 into pi by 2. Tan of 5 into pi by 2 is same as tan of pi by 2, which is not defined for you. So that for just eliminating that thing, what we did is we changed this tan of 5x as sine of 5x into cos of 5x. That is same as limit x approaches to pi by 2. We can even take this limit in the like power directly. So even this limit can directly be calculated, 4 by 5. Tan of 4 into pi by 2. This can be easily calculated, so we can put the limit along with it, which does not have any issue. We can put the value directly where we don't have any issue for some functions. Here we have 5 into cos of 5 into pi by 2. We can just remove this limit part over here. I have just input the value of x, right? So now just calculate. This is same as 4 by 5 whole raised to power tan of 4 into pi by 2, that is same as tan of 2 pi, that is 0. You have 0 by, this is tan of 5 pi by 2, tan of 5 pi by 2, that is same as tan of pi by sine of pi by 2. So sine of 5 pi by 2 we have same as sine of pi by 2, so that is 1. And this cos of 5 pi by 2 same as cos of pi by 2, which is same 0. So this is 4 by 5 raised to power 0, that is 1. So you have k plus 2 by 5 same as 1. That implies k is equals to 3 by 5. Okay, so you were supposed to calculate the value of k, and your k value over here is 3 by 5. Okay. Let's just move to the next question. Like 2 to 3 questions were mainly based on this thing only, that your function is given out to be continuous to you. You were just directly applying the definition of continuity, but while calculating the limits, you were using 2 to 3 results for limits chapter. So if you are not able to do such questions, that means your limits portion is weak, right? Your continuity portion is not weak. You need to practice on limits more. Okay. Here's the next question. It is statement type problem which is given to you. Consider the function f of x is equals to greatest integer x plus 1 minus x, where x is from this function is defined from -1 to 3. Okay, and this denotes greatest integer function that we already know. Statement 1 is given to you. F is not continuous at x equals to 0, 1, 2 and 3. Okay, and statement 2 over here is this f of x is equals to this, right? So to check this particular question, whether that statement 1 or 2 is true or whatever it is, what we will do is we will just rewrite this f of x as this, like basically we will split this out for each particular interval. So let's just split this out first. Okay, we have this function with us. So let's just split. F of x is for x belonging to -1 to 0. I'll just open it up so that easily I am able to write each and everything. So for x varying from -1 to 0, then from 0 to 1, then from 1 to 2, then from 2 to 3, right? We have these intervals with us. Now from -1 to 0 interval, greatest integer x would be same as -1 plus 1 minus x. 1 minus x for this particular interval, this would be positive. You can input any value in between this interval. You can see that this function 1 minus x would be positive. So you can write this function as it is without the symbol for absolute value. So you have this function as minus of x, right? So for this particular interval, you have your function as minus of x. Now let's just check for the second interval. Second interval is from 0 to 1, right? From 0 to 1 you have. So for 0 to 1, greatest integer of x is same as 0 plus from 0 to 1 you have the second function to be positive, still it is positive. So you have 1 minus x as it is. So it remains out to be 1 minus x only. Now from 1 to 2, check for 1 to 2. From 1 to 2 your greatest integer function will take the value 1 plus of 1 to 2, this value 1 minus x, 1 minus x from 1 to 2. If you put the value 1.5, right, 1.5 is there in the interval 1 to 2. So 1 minus 1.5, this is negative. That implies you need to reverse it. So basically minus of 1 minus x, that is x minus 1. So you have this as x because 1 and minus 1 would be cancelled. Now from 2 to 3, I suppose that you might be able to write this by now. So greatest integer function will take the value 2 plus of 1 minus x would take the sign, like basically it would be negative number because your numbers are greater than 2. So you will have x minus of 1 over here, that is x as it is plus of 1. This is what you have, right? So you have these bifurcation with you. Now let's just first check for statement 2. Statement 2 is easier to check by now. You have minus x same. 1 minus x, 1 minus x same. Here you have x, but here it is given as 1 plus x. That implies this is wrong. Even x plus 1, here it is given to be x plus 2, which is wrong. That implies your statement 2 is false. If your statement 2 is false, now let's just check for statement 1. Statement 1 says your function is not continuous at points 0, 1, 2 and 3. If you need to check for these points, what you will do is you will check the functional value at all these points. Now let's just check the functional value at all these points as well as left hand right hand limit. Okay, so left hand limit at x equals to 0 is equals to, from this interval you will be getting, that is same as 0, like minus of 0 we will have same as 0, and your right hand limit would be at x equals to 0 would be same as from this particular interval, which is 1 minus 0, which is 1. That means left hand limit and right hand limit is not same. That implies a function will not be continuous at 0. So 0 is checked. Similarly, check for 1, 2 and 3. So if you check for left hand limit at x equals to 1, that is same as at x equals to 1, you have left hand limit from this one. So 1 minus of 1, that is 0. And for right hand limit at x equals to 1, you will have just directly 1 put. So you have this as 1 and this left hand limit is 0. So 1 is again checked. You are not having your left hand limit and right hand limit to be equal. Similarly, check for 2 and just like check for 3 also. Here this is still 3 also, right? So you need to even check for 3 point. Here x equals to 3 you can also write. So you have this as 3 plus of x minus 1, that is same as x plus of 2. So you can even check for 2 from this and 3 from this. You will check see that your function is not continuous for 2 as well as for 3. So if your function is not continuous for all these 4 points, that implies this statement is true. First statement is true and second statement is false. So according to that, your answer would be A part. Okay, your answer is A part. Let's just check what next question we have with us. This is the next question. Again, you are having a statement type problem with you. Statement 1 says a function defined from real number line to real number line is continuous at x naught if and only if limit at that particular point of f of x exists and that limit is same as f of x naught. You can recall that this is the basic definition of continuity, right? This is directly true using the definition of continuity, right? Using the definition of continuity, this is directly true because here it is given that if and only if. So if it is continuous, then this thing limit is same as f of x naught, this would be true. And if limit is same as f of x naught, then reversely it is continuous. That's why if and only if we have. Okay, now let's just check for the next one. A function f from R to R is discontinuous at x naught if and only if and only if, again it is given to you if and only if limit f of x as x approaches to x naught exists and this limit is not same as f of x naught. Is it true that in this particular case your function is discontinuous? Because here it is given that if you have this discontinuity only if this thing happens, but even you have seen that discontinuity was also there if either the left hand limit or the right hand limit does not exist or if they are not equal. That means your limit does not exist. In all such cases you were even having the discontinuity, right? So they are not including that thing. That implies this if and only if thing is wrong over here. That implies your statement 2 is false. So your statement 1 is true, your statement 2 is false. That implies you will have your A part as your answer. Okay, so your A part is your answer for this particular question. This was directly using the definitions. Yeah, directly using the definitions or some results you have, right? If you don't know some results, you can even recall from the jump discontinuity or the removable point discontinuity, like you can recall from that points also, right? So with this, we are done with this session. Hope you have enjoyed this session and learned a lot from this chapter. If there is any confusion, just let me know in this comment box, and if you like the lecture, just write it down in the comment section so that I know that you are learning over here with us. And if you haven't downloaded the Practically application till now, just go to your Play Store and download it quickly. Surely I can say that you will be benefited from the lectures over there and 3D model videos we provide over there so that you have a better conceptual clarity. Okay, so we'll see you up in the next lecture. Till then, take care. Goodbye.